you. Let's go ahead and jump into it. So we'll start this clinic. Please follow along in the call agenda. So we should be in that bookmark section now under Earthdata Cloud Clinic, and we'll start off with the introduction and background. So Erin, thanks. You already gave a really nice introduction to kind of some of the goals, but just to reiterate, this is a brief introduction to the Earthdata Cloud. So we'll be showing a couple of kind of smaller, toy examples, if you will, to kind of get, introduce you to some of the sort of breadth of resources that are out there. But part of this as well is getting introduced to this shared cloud compute environment. I know some of you already kind of have spun that up, which is great. You're already a couple steps ahead, which is wonderful. But that's sort of part of this. And then we'll also kind of jump in using a Jupyter notebook on how to find and access cloud-hosted data. So as Erin mentioned, there's several of the mentors in attendance today. If you have questions, so please, put questions into chat, raise your hand. We'll also be using some of the Zoom reactions in a little bit to make sure that we're all kind of following along and we're not stuck kind of getting set up in the hub. So the other thing that I'll note, and I could throw it directly in the chat, but it's in the third bullet under introduction and background, the notebook that we'll be walking through is also, I'm highlighting that right now, I'll put it in chat. This is also available in our Earthdata Cloud cookbook. So there's a direct link to that. So kind of worst case, you can kind of just follow along statically kind of through that web-based rendering of the notebook. But the goal is for us to be interactive today and actually be coding together. And then the last bullet in this intro, there are some materials listed. And I think I'll go ahead and jump in and start sharing my screen now as we get into this. All right. So this pre-hackathon clinic, I'll also just open this up so you can follow along. There are several resources. You have to look at the navigation at the bottom here, but there are several notebooks that go into more in-depth information when it comes to our cloud environment, notebooks, Python, Git, GitHub, more background on Earthdata logins. This is also great background that, again, we're going to kind of breeze through today. So we got some resources in our back pocket. Any questions before we kind of jump into the setup? Okay, let's jump into that next section under setup, and we're going to move into logging into the hub. So that's step one, logging in. Go here. So everyone, go ahead and click that link to openscapes.2a2c.cloud, and I am already logged in, but we have screenshots at the bottom here, so you can kind of see what will happen once you click on that link. It's going to bring us to this CI login page. I'm also going to open up my chat as well to make sure I'm following along here. Yeah, thank you for throwing links in as well. So you'll get the CI login page, and you'll follow along with the defaults. So GitHub should be selected as your identity provider. You can click remember the selection if you wish. You don't have to, and then click log on. And you should be prompted at this point to log in with your GitHub username and password. So this is the one of the key pieces that we needed for today. So if you have that username and password handy, you can authenticate there. So let's just give folks 1 minute to do that. At least as far as I know with my GitHub setup, that I have two-factor authentication. So I get a text and then have to add that code in. Give folks a minute to sign into GitHub.
Okay, that's great. Malambo or Lonesome, let me add you. Thanks for sharing.
Yeah, please let us know if you're having any trouble at this point.
Okay, Lonesome, you should be able to refresh. Is anybody else having trouble? You were asked
Great.
for
So
server
server
options.
options. Great. I'll jump into that. So for folks who have logged in and are on the next step, so this is the next thing that should show up here is you get these server options. So the default which you should have selected, is the first option here, which is small. And then under that, it says image, Python, and then some more information about the compute resources. So that's the default we'll stick with. So go ahead and keep that selected, and you can click the start button. So we are using Python today, and we'll show that interface in just a moment. We do have other options under the image selection, including MATLAB and R, which we won't go into today, but those are available. All right, so that should take a few moments for the hub to load, and be patient. Again, it may take a few moments. In the meantime, I'm going to pop over to my JupyterLab interface, and I'm going to kind of give you a very quick orientation to what you'll see. So once it loads, it should look something like this, where again, we're in a JupyterLab interface, and I'll highlight a couple of important components here. The first is on this left-hand navigation, what should be shown by default is a file browsing sort of directory structure. So just like you are browsing your own computer for files, you can do that here. So you can really look at this and think about this like you're working in your own computer, and you can customize this. So as you can see, you probably don't have all of the folders that I have. I've customized this, and this will persist, you know, into the future once you log in. So I've kind of created another repos folder. Again, you can customize this much as you'd like. You should see though the shared and shared read write folder. So that should be available for everyone. And we'll navigate into that shared folder in just a moment. Another thing that's handy, so again, by default, you should see this launcher window show up. If at any time you close out of that, you can click this this blue plus button at the very top, and that will open up this launcher. So this is a really easy way to kind of get started and open up different applications that are available to you in the JupyterLab interface. You can click on Notebook. Under Notebook, you can click that button, and it will create a new untitled notebook, Jupyter Notebook files. That's that IPYNB extension. I'll close out of that. And then the other handy option under Other is a terminal button. So if I click on that, I now opened up a terminal, so I can interact on the command line. So if you're familiar with command line commands, if I went ahead and did PWD for print working directory, that's a sort of common one of my go-to commands. I'll see kind of where I'm at in my directory. So I'm in this home Jovian directory. So a handy resource for kind of navigating in the command line if you're familiar with that. And great, I think maybe we'll handle questions at the end, or feel free, mentors, to jump in and you can answer Chris's question asynchronously. All right, I think those were the key things that I wanted to show. The other handy thing, and I'll do this once I jump into the notebook, is there's this file icon at the top left, and you can actually collapse that. So that's kind of handy if you just kind of want to, have just your terminal window open or whatever application open. You can collapse that and click that button again to open it. So I'll have that collapsed once I open up the notebook that we're working in today. All right, I'm going to pop back over to the call agenda. I think I went through all the pieces that I was hoping to walk through in this quick introduction. So I want to make sure we're kind of all logged in and we're good to go before we jump into the notebook. So if you go into your Zoom, you should see a reactions icon at the kind of, I don't know what you call it, but the toolbar that you see in your Zoom screen. And if you click reactions, you should see these pop up. So go ahead and click the green plus. So Julie just did that. You could see that's over her video. So click that if you are in the JupyterLab interface and are able to follow along, and click that X button if you're still stuck or need assistance. We'll make sure everyone's good to go before we move on. Oops, now I'm gotta move my window out of the way. Yeah, so again, click that green check if you see you're kind of logged in and see this Jupyter lab. And I still see some blanks, so I don't know. Please check the X if you do need assistance, and we can, as Erin was saying, we can maybe get you pulled into a breakout room and help further.
And if you don't see the reactions, maybe Chris, you can write in the chat like, yes, I'm good, just so we're just trying to get a sense.
Yeah, right. If or maybe more important, if you're stuck at any, if you are stuck and need assistance, holler. You can feel free to jump off mute as well. It's a fairly small group. Yeah, thumbs up. Okay, I don't think I see any red. So I think I'll go ahead and move on. Again, please raise your hand or pop into the chat if you need anything.
We could also we could just give it another 30 seconds just to see if folks are sick, make sure everybody's here.
Yeah, definitely. One other thing that that I have changed, so one other kind of fun setting, if you go to the top at the settings, this was like fairly recently added. You could do like a dark mode or a light mode. So I'll stick with the light mode, but this is kind of nice, especially it's a little easier on the eyes if you're working at night. Another, you can customize that, and that will persist as well. So I'll switch back to the light mode though for today. All right. Oh, well, I will start moving into our step 2. So we are what page still? So we're on page 6. You head back over to the call agenda. So now we're going to open up our notebook for today. So the directory where to navigate is under this step 1. So we're going to pop into shared, head into the Earthdata Cloud Cookbook. So this is actually a copy of our GitHub repository that is used to create that website for that Cloud Cookbook that we showed earlier. And then we're going to navigate to the examples folder in Earthdata Cloud Clinic. So I'll go ahead and do that as well under shared. So you just double click into there like you would with any other kind of file directory browser, pop open the Earthdata Cloud Clinic. And we're going to go under examples. And it should just be towards the bottom here with this little notebook icon. You can go ahead and double click that and it will open it up. All right. So give you a minute just to navigate over there. And then once you have that open, we actually rendered all of those cells to have them kind of show up in the website version of this cookbook notebook. So we're going to actually clear all of that out so that you can follow along on your own. I have a different templated copy that's totally wiped out the code. So I'm actually going to type this in real time. But for everyone else, feel free to just go ahead and clear all outputs. So how we do that, once you have the clinic opened, you're going to go into this kernel menu at the top. And you can click Restart Kernel and clear all outputs. And it's going to give you a little warning. Are you sure you want to do this? All variables will be lost. And so say yes and restart this. This is always, I find this a really handy tool if you just kind of want to refresh your your current settings and just clear out everything that you've had. So if you've had code running and just kind of want to wipe it out and redo it, that's a really handy trick. So I think I'll leave it at that for now. Again, make sure to do that so that you can follow along here. Okay. And I'll bring up some of these Jupyter Notebook tips as we jump into the code. So I'll head back into this in a minute, but if you're not familiar with Jupyter Notebooks, there's some handy ways to actually execute the code chunk, but I'm going to start with a little bit of introduction and preamble before we jump into this. Okay, great. All right, I'm going to pop over to my template here and go ahead and kick off. But again, just raise your hand to let us know if you're stuck at any point. Okay. So let's
So
jump into the.
Sorry, I'm not quick enough to type or raise hands.
Yeah.
I just had a file changed pop-up window to cancel, revert, overwrite.
Yeah, I saw that as well, and I'm wondering if because we're all working in this shared folder, if this is going to keep happening. I'm thinking on the fly here, since so essentially in the shared folder, everyone kind of has read-write access. So we're kind of all working from the same file right now. I'm wondering if if everyone should copy this and kind of rename it with their initials. I don't know, I'm kind of thinking on the fly here. And then what that'll do is I think you'll then see everyone's notebook copied, but then you'll kind of have your own notebook to work from. That makes sense, other mentors. I know in the past we've kind of used Git, but we were trying to simplify by just all working from a single shared file. I wonder if we should do that.
I think that works, Amy. I just right-clicked and duplicated the notebook. So I'm seeing copy 1 and copy 2.
Yeah.
Looks like people are starting to do that.
Great. Okay, perfect. That is perfect. So yeah, I'll actually X out of this as well. Well, yeah, I think, right. So just right click on Earthdata Cloud Clinic. And I'll kind of just get rid of that one. Right click and then duplicate. Yeah.
And then you can right click again and rename.
Yep. So once you have that copy, right click again and then just click rename at the top. I guess you can use F2. Yeah, this is good. I didn't foresee this happening, so I'm glad we're all able to kind of make some changes on the fly here. So yeah, this should kind of keep your own notebook untouched to others. Yeah. Okay, I'll give folks a minute to do that. And we do want to stay kind of stay in this directory. So don't move the notebook anywhere. Just duplicate it. Since we will be kind of calling from a different directory, or we'll be calling from the data directory. So we want to stay here. All right. Give people just one more minute to kind of create their copies.
A quick question to the mentors. I just tried going to earthdata.nasa.gov and I'm getting a site can't be reached error.
Yes, there just, I want to say 2 hours ago, I saw that apparently there's a much larger like nasa.gov domain outage happening. It seemed to be a little intermittent. Like for me, I was able to access the site. So this is like big, and I think that the nasa.gov folks are on it. But
Okay.
Yeah, there have been some issues, unfortunately.
Thanks.
Yeah.
Just to let you know, I closed down the window of the original Cloud Clinic presentation or notepad and opened up my own, from which I do not get the notifications anymore.
Yes. Yep. I did the same thing just now. I got that pop up and just kind of clicked revert. Okay, great. All right. So once you have your own copy opened up, hopefully you won't get that error again. So I'll jump into the summary and kind of keep chugging along here. So remember, once if you hadn't done this already, make sure to go into, once you have your copy notebook open, go into the kernel and click restart kernel and clear all outputs. Okay, so we're going to jump into 2 different direct cloud access and subsetting options available in, yeah.
Sorry, would you mind
No
showing
problem.
us one more time how to clear our kernel?
Absolutely, yes.
As well?
Yeah. So if your notebook's opened up here, you're going to go to kernel at the top menu. And under the kernel menu, you'll click restart kernel and clear all outputs. So it's going to again give you a warning, are you sure you want to do this? And then click restart. Great. All right. Thank you. Please continue to interrupt, being to pause or reiterate anything. Okay, so these two different access methods. The first one, we'll be working with a Python library called Earthdata. This is for data searching and direct cloud access. And we'll also then be working with the Xarray library to subset the data that we accessed from the cloud. So the data set we'll be working with here, this is from PODAC. This is the Measure Sea Surface Height Anomalies data set. So we'll inspect this in a little more detail once we jump into that section. And again, there's links to the Earthdata search, but we'll kind of skip over those given the those DNS issues taking place right now. And then the second option that we'll explore is the HarmonyPy Python library. This is another option for direct cloud access and also data subsetting. So we'll work with a different data set. This is also coming from PODAC, so we'll be kind of focused on ocean data today. This is the GRIST level 4 MIR Global Foundation Sea Surface Temperature Analysis. And those links take you to the PODAC landing pages of those data sets. And we'll be working with a vector-based geospatial file to input as our subset area. So in both scenarios, we're accessing data directly from AWS, Amazon Web Services. And in particular, we're working within one of the regions where data are stored and where you can sort of work with compute resources. This is the US West 2 region. And that's where all NASA cloud hosted data reside. So where you are right now, when you logged into that openscapes.2i2c.cloud, we're all working from, this is running in that same location. So this is, you might have heard this term before, with analysis in place and sort of working with data like co-located in the same place where your compute is. So that's sort of the concept here. And then again, in both cases, we're going to be loading those data into Python as an Xarray data set. So this is based on several other tutorials, and we listed those resources at the bottom of this notebook. So I mentioned subsetting, and just a note on subsetting. So in addition to kind of directly accessing those files as they are archived and distributed by each of the NASA DACs, many of our data sets also support services that allow us to customize those data. So that can mean via spatial or temporal or variable subsetting, reformatting the data, maybe doing some geospatial transformations as far as reprojection and regridding, as well as file aggregation. So just to a little note to dive a little bit more into what we mean by subsetting. This is kind of a little bit of a depiction of what we mean. And this is an example of spatial subsetting. So in this case, we have some level 2, this is the SMAP mission, so some level 2 swath data overlaid across the United States. And our region of interest is the state of Colorado, so it's a really easy example. And I live there, so it's a good one for me. So we have our box, this is our region of interest. When we filter data, so we'll be using Earth Access to say, hey, I want data over this location. This is kind of what we mean when we say like filtering the data. So we'll get everything that overlaps that region. But there's sort of a next step of actually subsetting the data. So in this case, the data are cropped fully to that region. So that's what we'll be showing as we move into some of these subsetting examples. And that same thing is true when we talk about variable subsetting. We say we just want, let's say, 5, 10 variables out of maybe, let's say, the hundreds that might exist in a particular data set. That service will actually extract just those variables. So this is really handy from a data kind of volume reduction standpoint. As data are growing, a lot of new missions, really, really big files, several gigabytes, that makes access difficult. This is a really handy way to reduce that volume and make it a more streamlined workflow. Another note is that talking about this as direct cloud access. You might also hear this called direct S3 access or simply direct access. And then subsetting also sometimes can be synonymous with transformation. So we'll talk a bit more about that further down. So some of the learning objectives today, we're going to utilize Earth Access, as I mentioned, to search for data using spatial and temporal filters, explore those search results. We'll perform in region. So again, working in that same Amazon region, direct access the data from an S3 bucket, extracting variables and spatial slices using Xarray, and then we'll plot the data as well using that library. And then we'll move into data subsetting services provided by NASA Earthdata, including Harmony. We'll work with a Polygon GeoJSON file, and we'll plot that and kind of inspect that using the GeoViews package. And then again, we'll work with the Harmony Pi library to request data, in this case over the Gulf of Mexico. All right, jumping into the code. First, some prerequisites though, before we do that. We're going to import our Python packages and we'll set up authentication. So that's needed for both our access and subsetting methods. So another point on this, the code that we're running, we do need to be running this code within that US West 2 region. So where the data reside in Earthdata Cloud, they live in these S3 or simple storage service buckets. Essentially, it's just their sort of location of the data. And access to those is provided via temporary credentials. So this location is required for that direct access. So the idea that we're not necessarily having to transfer or move data around from place to place, we can access it in place. So while this code requires that, in this case, for the Harmony example in particular, just a note to emphasize that all data in the Earthdata Cloud are still freely available via download. That's still an option, but we're showing the direct access case today. All right, so let's jump into importing the required packages. So some of the notes I mentioned earlier, some tips that were in the call agenda. For those of you unfamiliar or haven't worked with Jupyter notebooks before, so a couple of quick tips to run code blocks. If you click either to the kind of outside of the box or even within it, that box will become highlighted, and you'll know that when you see this blue bar on the left. So once that's highlighted, you can either click this arrow at the top, that play button, and that will run the code block. So I can go ahead and do that. Another way that you could run a code block, if you have that highlighted again, you can hit Shift and Enter. So Shift Enter should work for both the Mac or Windows machine. And this is going to take a minute. There's a couple of packages that take a minute to load. You will see sort of a warning message at the bottom. This is from one of the GeoViews packages, and it's sort of just giving a warning on something that will be deprecated. So no need to worry about that for now. Another helpful tip, I don't know if you noticed this as you were running the code block, but as the code block is running, you'll see this asterisk in brackets on the left. Once that code block has been run, you'll see a number in brackets, and that designates the order of sort of the sequence of that code block. So I've run this 3 times now, and that's where you'll see that number 3. So subsequent code blocks will, you'll see 4, 5, 6, etc. All right. So some of the packages that we imported, we had some warning suppression that we imported. Oh, this is handy if you're sort of getting warning and just don't want to see it in the future. A couple of imports for our direct access example, importing the Earth Access library, a pretty printing function, importing Xarray, and then under Harmony, a couple of geospatial packages. So we'll be working with GeoPandas, GeoViews for some of that plotting and extensions on those, importing the Harmony Pi library and a couple of methods under Harmony, a date time package that we'll need for that request, something called S3FS that we'll talk about later, and then matplotlib so that we can see our plots inline. Okay, so now jumping into our authentication. This is our first step. I know we asked, make sure you had your username and password handy. This is where you'll input it right now. So again, for those of you who've just kind of refreshed your kernel, you can just go ahead and run the code block. I'm actually going to type it live right now so I can explain it in a little bit more detail. So we'll be using the Earth Access library to authenticate, and this will allow us to get our cloud hosted data. So I'm going to call this auth, earthaccess.login. And the strategy that we're going to be using, there's a couple of different ways we can authenticate, but we'll be using the interactive strategy. And that will give us a prompt to enter our username and password. Persist equals true, and I'll explain what that means in just a moment. So you can go ahead and type in your Earthdata login username here, as well as your password. And you should get a note saying you're now authenticated. It gives you a date on when your token for authentication expires. And then this last line here says it's persisting credentials to a netrc file. So this persist equals true flag allows us to have this file that lives in our home directory, and that will sort of authenticate sort of in the background. We'll actually use that. It'll be needed for the Harmony step. So that all happens in the background. And we have some resources for more information if you're curious about netrcs at the bottom of the tutorial. I'll pause here for just a moment, since I know this was another, sometimes another step that if there's maybe credentials added incorrectly or any issues with authentication, I know sometimes people can get errors. Yeah. Okay. Seems like a couple of people are getting errors here. Folks, just another minute. And I don't know if our mentors could work with Chris or Barry. Maybe this is another good time for a check box. If people see that you're now authenticated, maybe add in that reaction and just give a check.
I would like to post a screenshot, but I'm not able to.
Chris, maybe we've got a troubleshooting section at the bottom of the clinic. Could you post a screenshot in the doc there?
Yes, stand by.
That's right now on page 7, and maybe a mentor can have a look.
Yeah, thanks. And certainly, if I'll keep moving along in just a moment, but you can certainly still at least sort of continue to follow along on the notebook that's in the cookbook that we linked to. But we definitely want to make sure you can kind of get through this step. I know it's a required one we've certainly made easier using the Earth Access Library. We want to make sure we can all get there. Okay, so we've had a couple of yeses, maybe like a mix or so.
So Chris, I wonder if you ran the cell above the Earth Access login. Amy, if you can scroll up just a second to that first import.
Yes, I would like to just post you the error I got prior to that.
Yeah, so we definitely need to make sure that this code block is run. You probably see, you should see these little icons indicating that everything was successful, but we do have to import Earth Access.
And I don't know, Julie, if you want to create a breakout or if we want to just keep going and keep people together, and then we could troubleshoot at the end.
Yeah.
Yeah, Barry's pasted her screenshot in the troubleshooting section as well. Do we have breakouts already set up? Steph, we can hop in the breakouts if you want to just take a minute.
Julie, I've opened 4 breakout rooms. I'll say, don't everybody go rush to breakouts. They're there so that if a specific pairing is identified, then they're there for people to go to.
Thank you.
Great. Okay. I think I will I'll keep moving forward here. Hopefully we could get some of those errors resolved. Yeah, in the breakout room or through the troubleshooting. So go ahead and move forward. I think got most people up to this step, which is great. Okay, so this graphic I think is really great, and this sort of describes Earth Access in a nutshell. It's an open source library to simplify Earthdata cloud search and access. So jumping into a little more detail about Earth Access, now I'm in the search for data section. Earth Access leverages the common metadata repository to search for collections and granules or files. So this is a really big, powerful metadata repository that powers a lot of applications, not just Earth Access leveraging it, but also Earthdata Search that we demoed last time. Also uses that kind of behind the scenes to find and filter data down. So we're going to now go ahead and search for data. So we're going to jump back into our example using the measures data set to find our data. So one way to do that, I already have these links kind of popped up, but I know again these DNS issues today are probably not helping. But I have the measures sea surface height anomalies. That was this link below under the first option here. I have that already loaded up. This is the PODAC landing page. And one easy way, if you already know the data set of interest to search on that data, is to grab the data set short name. So in this case, for PODAC, this is going to be listed right under the full name of that data set. So this is actually a fairly long short name in this case, but this is actually what I'm going to copy over and I'll use this to search on. All right. So I'm going to just declare that as SSH for sea surface height short name. And I just copied that from the landing page. And then we'll use that as what we'll use that as input for our search. So I'm going to call this results, earthaccess.search data. And this is where I'll type in all of the parameters that I'm interested in to search on my data. So data set short name. This is optional, but there's an option to say I only want data that are cloud hosted. Not all data currently have been fully migrated into the Earthdata cloud. Some still reside at individual DACs. And so this will sort of ensure that the data we get back is cloud hosted. So I know that for PODAC, in PODAC's case, all data now are cloud hosted. And then temporal. So in this case, I'm interested in sea surface height anomalies over the summer. So I'm looking at the 2021 example, and I'm going to search from July 1st through September 30th. So I'm going to grab a 3-month window of data. And I'll go ahead and hit Shift Enter to run that code block. And what's really nice is that Earth Access will tell you how many files were found. So if I were to pop that same search into Earthdata Search, for example, you'd get that same number of files. And so this makes sense if we kind of inspect the data landing page and look at our description. These data are provided on a 1/6 degree every 5 days. So we should be getting 6 files per month. We're looking at 3 months of data, so that makes sense. We get our 18 files back. And then using Earth Access, we can print those results, and I'll use that pretty print function. And in this case, I'll just grab the first result back, and we'll get the metadata back on that first file or granule that was returned. So there's a lot of information here as far as the size of that file. And then in particular below, a lot of links and information on how to get the data. So various get data links, so you can click, the HTTPS link and get the netcdf file downloaded. Information about that S3 location we'll grab in a moment, and then other information just about the spatial extent, etc. So this is handy if you just want to kind of inspect this sort of programmatically within your Jupyter notebook. And now we're going to go ahead and access the data. So this next set of code, this will work. Really wonderful about the Earth Access library is that you can use the same code whether you're in the cloud or not. It actually sort of knows whether you're running this code in region. So since we're working in the AWS US West 2 region, we can stream the data directly to X-Ray. So we don't have to download it first and move it. And we're going to use the X-Ray OpenMF dataset or multi-file method, which happens to be required for Earth access. That's sort of the right method that we want, given that we have 18 files. And we're going to open those all at once. So we'll call this DS for dataset. And we'll go X-Ray OpenMF dataset. And I'm pointing it directly to the earthaccess.open results. And then I'll type DS at the bottom so that we can sort of print out that Earth access data set. So right now it's grabbing those 18 granules and opening them up. And what you'll see below, since I printed out the data set, you'll see the X-ray data set. So all 18 files in that single line, just coming from the results that we searched on, is going to create a single sort of data cube where we have 18 time dimensions across our lat and longs. Okay. I'll pause here, making sure. Checking the chat. Okay, great. So we have our data cube pulled into X-Ray. And now we'll go ahead and subset our data. So in this case, we've grabbed the data sort of whole as is, as it's archived, and we're going to use X-Ray to subset that data set. We're going to extract the SLA or the C level anomaly variable, and we'll slice the data set by a smaller area of interest near this data Baja. And just scrolling up before I do that, there's a couple other things you can inspect within this X-Ray data set. So there's some coordinate dimensions. We see longitude, latitude, and time. These are the data variables that are contained in that file. So you have some bounds, and then again, SLA, so that's our sea surface level anomaly data set, variable, and then our error. And we can kind of collapse and expand those as well. That just gives us a little bit of an idea of what's contained within that data set. Okay, so let's go ahead and now do that subset. So I'm going to create a new data set, ds_subset, and I'll take that original ds and I'll grab just the SLA variable, .cell for selection, and then I'll take a slice of my latitude. So I'm interested in from 15.8 to 35.9, and then longitude. Just grabbing my window here. Skipping that over. Okay. And then longitude equals slice 234.5 to 260.5. And I had a parentheses instead of bracket on my SLA. So that should look good. Okay, and then we'll print out that DS subset. So in this case, yeah, I'm interested in this area of interest near the state of Baja, Mexico. And now I can see that the subset, it just has my SLA variable, still has that time across the 18 time dimensions. And now we can see that the latitude and longitude, though, is a lot smaller as far as the number of grid cells. And now we can use a built-in plotting function to plot that out, see what it looks like. And in this case, I'm going to take the subset and I'm going to grab the standard deviation. So I'm interested in that deviation over that 3-month period. So we'll take standard deviation over time and we'll plot, and I'm just setting some figure size dimensions to make it a little easier to read, 10 by 6. X equals longitude, Y equals latitude. Okay. And voila. So originally this is a global coverage per file, but now we've subsetted that down and we're able to plot and kind of see some changes over time. So simple example, but it really, I think, highlights some of the power of X-Ray, kind of how you can do that slicing and subsetting after having the data in hand. Okay, so that's our first example with Earth access. Tab on the time here. Okay, great. And we'll move over into HarmonyPy, our next example. And let me know, mentors, if I should pause for any reason, but I think otherwise I'll just jump straight into HarmonyPy. Okay, so in this case, we're now going to be accessing a NetCDF4 file using transformation services in the cloud. So using Earthdata search, again, this website might be down at this point. I think I showed this at our last call, where you can use a customizable filter to find data sets that have these services available. Not all of them currently do. So in this case, this GRIS data set, and I have that landing page open, that's linked at the top of the notebook as well. In this case, in the Earthdata search, you can see that that does have some subsetting options available for this data set. So it's another level 4 data set. And we'll go ahead and find request and open that data using Harmony below. So in this case, and I think one of the values of using Harmony is that if you have an area of interest, in this case, a shapefile or some sort of vector file that describes the area of interest, you can actually send that, sort of say, I only want data over this area, and that cropping will be done sort of for you and processed for you, and the results delivered back to you. So first, we're going to use GeoPandas to read in that GeoJSON file containing the polygon feature. So first, I'm going to specify my path for where that data lives. That's in the data folder of the repo. So data/gulf.json. And then we'll use GeoPandas, and we'll create a GeoPandas data frame. So GDF. We'll use GeoPandas or GPD to read that file in. And this is going to return a geo data frame object. So I probably typed in something wrong. I wonder if I'm in a different folder here. Let's see. I'm wondering actually. Just checking things. Let's see here. I wonder if I typed something wrong. I can come back over. Curious if others are getting this error. They should be in the right path.
Mine worked okay, Amy.
Did it? Okay.
Yeah.
I'm in a weird
Same
place.
here. I wonder
Oh,
if
you know
I'm looking
what?
at the top.
Yeah. I think I'm in the wrong folder somehow. Yep, my notebook moved. So let's see here. I'm going to do, actually going to use a command to, so if you do the percent sign, you can kind of interact with the command line. So I printed out my working directory. It looks like I'm in the home directory. So I think I can cd to, let's see here, doing this on the fly. Earthdata Cloud Cookbook. Let's see. All right, let's try it now. Okay, good. I'm back. I must have switched over. So this is really handy if you see that you're you don't know kind of where you are. Again, you can use this called a magic function to kind of interact in the command line from the notebook itself. So I use cd to change directories into my correct directory. So, all right, woo, I'm back. All right, so if I add GDF at the bottom here, just to see what we have. So I get some information back. I see I have some polygon metadata. I could kind of start to see the coordinates here. So great, we read it in correctly as this GeoPandas data frame. And so now this is actually great. I learned this from another Openscapes mentor, how to just inspect the file and see, hey, is this over the area that I do indeed want? So we can do some plotting here. We're going to use the GeoViews package with those extensions that we imported earlier. So we'll call this base.gv. And what's great about this library is that it has sources of base map imagery. So in this case, I'm going to grab Esri imagery, and I'm going to grab some options here. So sort of make this a little bit prettier. The width is 650, height is 500. And I'm going to call this ocean map. And I'll do gv.polygons, GDF, and also specify some options. So I want the line color to be yellow and the line width to be 5 and color none. Okay. And then we can use this asterisk. I need make sure that I have that correctly. Okay. Oh, yep. It looks like I didn't have a needed to add another. There we go. All right, so that should work. Color equals none. And then we can use the asterisk to view that polygon over the base tile map. So base and then ocean map. All right. So this is really handy, just a nice way to see, yep, we popped that polygon in and we do indeed see that it's over the Gulf of Mexico.
Amy, do you mind just pausing on your code just for one more second, just so folks can see it?
Yeah,
awesome.
Absolutely.
Thanks.
Yep, so again, we kind of specified some widths and heights to just make it visually a bit more appealing, but we pulled in this Esri imagery, and then it was gv.polygons to read in the GeoPandas data frame that we just specified above with yellow line cover, and then we can plot that base along with the ocean map together. Great. Okay, so now we'll move into the subset request, and we're going to essentially import or upload that GeoJSON file to the Harmony service to do that processing sort of on our behalf. So first we're going to create a Harmony client, and we'll use this client to interact with the job submissions. So we'll just call this Harmony client equals client. And now what's happening here is this line assumes that we have a NetRC available. So this is, again, a file that has our authentication built in, and that was actually created above in that Earth access step. So this, if there's any errors here with authentication, but this should all work as expected since that NetRC was built with the persist equals true flag above. So now we kind of have our client ready to go. And you can see the Harmony Pi documentation for more details on kind of how to construct your request. But we'll now go ahead and build that request that we'll submit to the Harmony service. I'm going to call this request, and then we'll use request, the request method. And actually first need to specify my short name. So I'll use the same kind of method here since we're interested in this mirror data set, and I have this uploaded already. Again, that's in parentheses on the PODAC dataset landing page, so I can copy that in here and specify. So in this case, sea surface temperature. So collection equals collection, and my ID equals sea surface temperature short name. And now we're going to specify the shape that we're interested in subsetting against. So all I have to do is specify that GeoJSON path that we created above. And then we'll create also a temporal subset as well. In this case, a little bit different as far as how we input it. We're now using the Python datetime library. And just given, just to make this kind of a simpler, faster example, we're just going to grab one single day's worth of data. So this will be just one file. In this case, we're just grabbing August 1st, 2021. So we'll do start on that and then stop. DT date time 2021 812. So in this case, we're just going to grab the first hour and the second hour, and that will just grab the first file of data back. Let's submit. And now we're going to go ahead and submit that request that we just constructed above. This will just take a minute, and you should get a code back. So this is that job ID. It's just sort of a long string. And we'll use that job ID to keep interacting with it. So basically what's happening now, we've sort of submitted it to this service. It's grabbing the file, subsetting it, and cropping it over that area. So now we can check on our request status. So we can use this Harmony client dot wait for processing. And we'll give it our job ID. And we can set this optional show progress equals true. Progress, not process. All right. So this is nice. It's already processed at 100%. Yours might still be chugging along, but this is nice. If it's a longer, bigger request, you can actually see this sort of, each file, you'll kind of see a percent increase along here. And what's nice about wait for processing is that if you have subsequent lines of code, it will actually block the lines of code from continuing until this is complete, which is great. So it'll say, hey, let's wait, make sure that we have all our data. So now we can take a look at the data that we got back from Harmony. We'll call this data. We'll use our Harmony client again and get our result JSON and specify our job ID. And we can pretty print that data. So this will give us back some information about that request. So we'll have some links available, and you'll see, in some of the links that we get back, we see this underscore subsetted to denote that, yeah, the file was changed and it was subsetted. Kind of move past that, but there's other helpful information about that to inspect your job. And then just like above, we'll move into accessing the data. So, the subsetted outputs are also available in S3 and can be accessed directly without the need to download them, but you can download them optionally. So again, this is helpful if you are still comfortable working with downloaded files, but you're really trying to reduce that volume down, given some of the kind of bottlenecks that can occur when you're downloading data. This is another helpful way that you can do that via subsetting and via downloading. Okay, so now we'll retrieve a list of output URLs, and we'll use Harmony client again. And we'll specify result URLs. So give it our job ID, and then we'll specify the link type. In this case, we want the link type to be S3. So we're just interested in those S3 links. And we'll grab the list of those results as URLs. And because that's a list and we just want the first and only, in this case, URL back from that list, we'll call this URL and just grab item 0 of that URLs list. So we can print that out and we'll see our S3 link that we got back from Harmony. Okay, so this next step as far as working with the Amazon Web Services credentials, this was actually done already. We did this using Earth Access example above, but it was all kind of happening behind the scenes. So with Harmony Pi, it's a little more front and center, and we have to do a couple of extra steps here to grab these credentials that are needed to access those S3 buckets. So we can still use the Harmony Pi library to do that. We'll call this creds. We'll use Harmony client.aws credentials, AWS_credentials. Oops, and extra period there. All right, and we'll get our credentials back. So now we're working.
Amy, this is Steph. I want to interrupt for a moment, please. Julie is asking if Chris could please join room 1 for some assistance, and if someone could also, one of the mentors could join Barry in room 2 for another question.
Yeah. Great. I'll give them a minute to join over there. Okay. So we'll jump into these next 2 lines of code to wrap up this tutorial. So we're now using this S3FS. That's for file system. So it's this Python package that creates a file system, and that file system is then read by Xarray. So what's a little unique is sort of this extra step's needed because Xarray can't actually open that S3 location directly. So it exists in what's considered a file object. And so that is then sort of passed into the S3FS package and then read into Xarray to open that data set. And before I jumped ahead here though, I actually cheated a bit. I'm not going to type all of this. It's a lot of underscores, but I'll run this and walk through what's happening. So we're going to basically set our file system using that S3FS package. And we're grabbing all of the different credential information that we get from this Harmony client.aws credentials. So there's an access key, secret access key, session token, and specifying the region. So all this stuff is provided by the Harmony client. We're passing all that in for sort of an additional layer of authentication. And now what we'll do is we'll just call this F, and we'll use the S3FS object that we just created .open. We'll pass the URL that we specified above from Harmony in read mode. And now we'll use Xarray .open open underscore dataset F. And we'll go ahead and open that up. So in this case, it's just that one single file. So it has a single time dimension. This is really high resolution data. I didn't go into much detail on the sea surface temperature data set. But this is on a 0.01 degree grid. It's a really high resolution. Need more information from the PODAC site. So this is also a global, originally a global data set, but we've subsetted it down quite a bit, but we still have a lot of these dimensions over lat and long. And as before, we can use the Xarray built-in plotting function to create a simple plot along the X and Y dimensions of the data set. But we don't have to do any of the slicing that we did with Xarray earlier since we already have that sliced. And real quick, Catalina has a great question. So these credentials that you need both for Harmony, but also the direct access example that we did above, these are only valid for 1 hour. There is a time limit. So you do have to refresh. Let's say you run this and grab those credentials that are working with other code. If you access again before grabbing and reloading the credentials, you may run into an access error. So this does have to be refreshed every hour. It's a good question. All right, so for the grand finale, we'll grab so ds dot. In this case, we're interested in the analyzed underscore sea surface temperature variable that we can see above in our DS, our data set output, and just use the standard plotting function. So again, this would be global normally, but we can compare it to the GeoJSON above, and we can see that this is just now cropped to that GeoJSON. All right, so that is those 2 examples. That's the end of the notebook. I do just want to point out some of the additional resources. So this clinic, yes, is based off of many other tutorials that all of the DAC mentors on the call here, plus many others, wrote, provided, and presented during past workshop events and other tutorials. So I have a couple of those links below. Other notes on other cloud services, and these some of these are also available in the cloud cookbooks. If you're familiar with OpenDAP, OpenDAP is also in the cloud, and there's a tutorial in our cookbook on OpenDAP. And then just a couple of bullets on support resources. Of course, you have us as DAC mentors to help answer your questions. We also have the Earthdata forum, and there is a specific, if you have questions on the cloud, you can specify that as you if you ask a question in that forum. And then we have several webinars across the DAC that describe cloud access as well. So I have a link to that series. I will go ahead and stop sharing, and hopefully we have some time for discussion and questions.
Great job, Amy. Aaron's got a question in the chat. Kick us off.
Yeah. Yes. So the question, Aaron, about why we need to do that S3FS step. It's a great question. So in all cases, when you're working with an S3, an S3 link, that S3 object, in all cases, again, it can't just sort of specify that and say, hey, X-ray, open this directly. So you do need to sort of create that file system to sort of do that handoff. That's the requirement sort of overall. Earth access is sort of doing something that's value added for us. So on the back end, it's kind of doing that for us. And I don't know, Luis, who's on the call, I think he's still on. I'm not sure if he had to jump off though. Maybe
He's in a
jumped off.
breakout room
Oh,
at the
okay.
moment.
Okay. Because I was going to say, so he's the lead developer on that Python library and could probably go into a little bit more detail, but that handoff is sort of happening on the back end. So, in that step above, when we sort of said, hey, X-ray, open MF data set, and then you just called Earth access, it's doing all that behind the scenes. So,
Great. And Tom.
I was wondering if this notebook would work on our local machines, or in the past, I've had trouble transferring the cloud access, but does Earth access, can it work from your local machine to access data?
yes. What's great, so if you were to take just that the number one section of that example before Harmony, using Earth access, you could run that exact same code. You wouldn't have to change anything if you were running locally. What would happen in that case, Earth access is sort of smart enough to know, hey, you're not running in the cloud. So it will grab the HTTPS links instead, and we'll download those. So it's again, it's sort of like doing all that for you. On the Harmony step though, you would run into an error. It would sort of say, hey, wait, I can't actually directly access S3. But again, with Harmony, you can still download the HTTPS links. We just have to modify the code to do that.
That's a great question.
I have a quick question. Yeah, it was a very helpful tutorial. Thanks for it. I was curious that if because I've run into this issue in the past that X-array is mostly works with netcdf file. Have you had any experience? I'm working with the HDF file, especially like when you want to process in a cloud environment.
Yeah, and other mentors, feel free to jump in. I can start. Yeah, so I know HDF5. It's sort of there's different flavors and different ways that those files can be structured. I know in particular there can be challenges when that HDF file has is sort of group structured, right? So you sort of have that hierarchy of data groups. In that case, and you have to specify each individual group. So we've certainly worked a lot on that guidance when it comes to ISAT2 data, which is HDF5 and grouped like that. And so I don't know if others could jump in on other resources or things that you've noted with HDF5 in particular. In general, though, this code should work. And netcdf is kind of actually a flavor of HDF5, but it really, I know, can sort of depend on the data set. But others, feel free to jump in if you have other thoughts.
Hi, this is Luis. Yeah, I think it's correct to assume that X-array works better with netcdf than HDF5. There is a incubator project within the X-array community to handle HDF better. It's called Data Tree. It's a contrib package from X-array. So what it does is basically transform each subgroup or nested group in an HDF5 file into an X-array dataset. It's still beta, but the thought in the roadmap is that will allow X-array to handle not just like gridded netcdf file, but any kind of unstructured HDF5. It's kind of complicated because, depending on how you package HDF5. It can be very complex. But there is some work towards that, and I'd say yes for now. Xarray is better with netcdf, and if it's a simple HDF5, you can specify the group, and Xarray will try to kind of decode the metadata that it needs to put it in a representation that is useful for you.
Okay, thanks. And do you have any like tutorial or examples that you can point me to, so I can read more on it, like specifying those groups and whatnot to have HDF work for with Xarray?
Yeah, there are some tutorials. Let me search for some, and I'll put it on the Google document. So if other people want to take a look, the one that I'm thinking of, it's a project called the Environmental Data Science book that has a lot of that information with Xarray. But a lot of those tutorials are being compiled into this project Pythia. That's kind of like a multi-tutorial for all kind of data science and earth sciences. So I'll send you or I'll put it on the Google Doc.
Okay, thanks.
And I'll also just note we have a simple example with ISAT2 data in particular. So again, that's specifying the group to use Xarray, and that's in the that's listed in the additional resources. I can also add it to the Google Doc. So that's also a one kind of basic HDF5 example.
Great questions. What other questions do you have or things that came up for you during the tutorial? Was this anybody's first experience using Jupyter Notebooks? Does anybody want to share how that went, or first time in the hub, how that felt?
I wouldn't put a great. Oh, I see Aaron's hands up.
Okay, so to me that was very helpful, and I think there's like stuff I could do like immediately. But I guess sort of like two important questions. If I wanted to use 2I2C to do something, what's the easiest way to get like code that I've already written up there? Like, would I manage that through GitHub, or like, can I just like copy files directly to these nodes?
I can, I can jump in, but others again, please chime in. So yes to GitHub. And I'm wondering if, maybe this could be a good co-working topic for next time, but there is an extension that's included in Jupyter Lab. Probably it's not refreshed in my head enough to give a quick tutorial now, but you can use that extension. So if you wanted to git clone and add, repositories directly into the hub, you could do it that way, or using the terminal command line to do that. You can also upload directly, meaning like you can drag files from your, let's say you have a folder on your desktop, you can drag that into Jupyter Lab as well in the directory panel. But those are two options. But I think Git is a great sort of method so that you're kind of interacting and committing and pushing those changes kind of within the hub. But again, if others have thoughts or ideas, they're just the two that popped into my head.
Okay, yeah, thanks. It does sound like a good co-working topic.
Yeah, and Aaron, it's also a good question about usage. So the 2I2C hub is meant for champions to experiment with, and so you are welcome to try anything you want to try on it. It helps us learn about different ways that people are interested in using NASA Earthdata on the cloud, and so we'd love to hear report backs of things that worked and didn't work, so that we can learn too. But this is a resource that all of you are welcome to continue to engage with moving forward.
A quick question. I should have written it down. I will write it in the doc. How persistent are the Earthdata credentials in the Jupyter Lab instance? And is that context dependent?
Yeah, so there's sort of, again, like 2 steps, but one of them is abstracted for you with Earth Access. So Earthdata login itself, since we set that persist equals true flag, that netrc file now exists in your home directory. So, and that, like, your Earthdata login account persists forever. I think they'll remove you if you're inactive after a certain amount of time. The cloud specific, so the S3 access credentials, so that's part of like the authentication you need for Amazon directly. Those persist only for an hour. So again, if you're using Earth Access and you're kind of working through that workflow, it'll grab those credentials for you and input those. But that's what you do have to refresh every hour. Does that answer your question, Chris? Or
Yes, thank you.
Yeah,
that's great. Yeah.
Amy, do you have to, when you're launching Earth Access, like every time you come back into the hub, do you have to log back into Earthdata every time? Or will it remember that?
Yeah, so the that netrc file, I believe that's going to live in your home directory. Like, you can log out of the hub, log back in, like it's there. You created it. Yeah, so you still would work with Earth Access to search for new data, access new data, but you wouldn't, let's say, have to use that persist flag. You wouldn't have to do a user prompt. I'm trying to think if we have examples of using a netrc instead, but yeah, so that should live on. I think that answered your question.
Yeah, it did. Yep. Thanks so much. And there's a quick question from Catalina in the chat. Does the Harmony subsetting service work with any cloud archive NASA data collection or only select ones?
So the latter. Yeah, great question. So currently, there's a growing number of data sets that support the subsetting services, but not all of them. So, again, using that customizable filter in Earthdata search can help you narrow down if you select both cloud and customizable. That may also, though, include data sets that are compatible with Openscapes, which is sort of a separate service. So that's, yeah, it's a bit hit or miss now. But we're continuing to grow the number of data sets. And if you are interested in a data set particular that you'd find to be really valuable to have those subsetting services, but doesn't exist today, like, please let us know.
Great. Well, seeing the time, we should probably, oh, go ahead.
One, just Malumbo, if you create a folder outside of the shared folders, it will persist for you. The group won't see it.